since the fundamental principles of electricity generation were discovered. At the start of the 19th century, humans have been able to harness the immense power of electricity, with countless inventions that have changed the world in which we live. For example, the subsequent invention of electric lighting was a pivotal moment in human history. Once humans were able to convert electric energy into light, civilization was able to make rapid progress like never before. Nowadays, homes around the world benefit from innumerable electrical appliances. For instance, we have air conditioners to help us stay cool in the summer, while electric lights help us to see in the dark. Indeed, electricity is essential to the progress and development of society. However, traditional power grids are facing many challenges in terms of operation efficiency and safety. Such challenges include how to support diverse power services, inspect inaccessible power lines, transform huge amounts of power, achieve visible power dispatching, and balance power supply and demand. These challenges have been in need of a solution for some time. This is where the smart grid comes in. What exactly is a smart grid? A smart grid is a next-generation power system that introduces a range of innovations to traditional power systems. Such innovations include new energy, new materials, and new devices, as well as advanced sensing, information, and control technology. Smart grids make full use of information technologies and are automated and interactive, better implementing safe, reliable, economical, and efficient running of the power grids. The ultimate goal of a smart grid is to achieve clean and environmentally friendly power generation, safe and efficient power transmission and transformation, flexible and reliable power distribution, and diversified and interactive power consumption. In this context, transforming traditional power grids into intelligent ones becomes of vital importance. How does a power grid work? Electricity is first generated at power plants by converting energy into electric power, which is then transmitted to substations through transmission lines. To reduce power loss and impedance drop on power transmission lines, and meet safety requirements of power users, power grid operators increase or decrease the voltage at substations and then distribute power from distribution stations to consumers for use. A power system consists of 5 parts: power generation, transmission, transformation, distribution, and consumption. The following analyzes these parts in terms of industry pain points, as well as requirements of smart grids. 1. Transmission line inspection is difficult to carry out. Let's take the inspection of high-voltage power transmission lines as an example. High-voltage lines are generally located in open fields and carried by towers or poles, placed 200 to 500 meters apart. In addition to the inspection of long lines covering a wide area, there is also a need to implement overgrown vegetation monitoring, ice coating monitoring, forest fire monitoring, and warnings about external damages to power lines. Currently, most inspection is performed manually, with only a small number of cameras and drones used for assistance. This makes inspection extremely difficult, with low efficiency and ineffective collaboration between drones. 2. Power transformation O&M is labor-intensive. Each substation is installed with many different types of terminals. With manual inspection, the process is time-consuming. Certain devices may not be inspected, and the inspection quality cannot be guaranteed. What's worse, the digital reconstruction of the devices faces multiple challenges. For example, substations have many high-voltage areas, presenting high risks in redeploying wired devices in these areas. In addition, a huge number of traditional meters are used, and these are unable to backhaul real-time status data to support automatic inspection. 3. The dispatching on distribution networks lacks visibility. Currently, 90% of the power distribution networks are not automated. Power outages can greatly impact production and daily activities, yet manual troubleshooting is highly inefficient. A power distribution network often has a large number of distribution network nodes that are geographically dispersed. Using optical fibers to transmit control signal between these nodes is costly, Yet 4G networks cannot meet performance and security requirements of most services. 4. Power consumption data cannot be comprehensively collected. Centralized metering is mostly used for collecting data of low-voltage meters. However, the collection frequency is low, and not enough data is collected, failing to support intelligent and personalized power consumption requirements. Traditional electric power grid operators mainly use centralized, in-person communication means to coordinate power supply and demand among diversified service nodes and phases, resulting in low communication efficiency and unbalanced supply and demand. They are in urgent need of an intelligent power grid solution to solve all these problems. What are the key requirements for building a smart grid? 1. In power generation, use 5G for power prediction and status awareness of new energies. 2. For power transmission, use 5G drones to monitor transmission line status and intelligently diagnose faults and generate warnings about risks, improving inspection efficiency. 3. Regarding power transformation, use 5G inspection robots and intelligent HD video analysis devices to perform intelligent inspection and real-time monitoring on transformation devices, achieving digital transformation of traditional substations. 4. On power distribution networks, use 5G slicing technology to implement telemetry, remote communication, remote control, PMU, functions, network load interaction, precise load control, and differential protection. This improves automatic management and reliability of power distribution networks. 5. At the power consumption phase, use 5G to intelligently and remotely monitor indicators of devices, such as meter boxes and electric meters, implementing advanced metering and collection of power consumption data. 6. Use 5G to implement planning, investment, and comprehensive governance of power grids. Based on the preceding requirements, we can see that wireless communication can be used into scenarios on a smart grid, control and collection. One solution that can meet these requirements and help implement smart grids is the 5G MEC wireless network. What advantages does this network have over traditional communication networks? Let's take differential protection as an example. Typically, power distribution networks use optical fibers or 4G for differential protection. This approach is costly, and the deployment takes a long time, not to mention it has poor communication performance, and fails to support collaboration between multiple networks. Using the 5G MEC solution, there is no need to deploy optical fibers. This accelerates service provisioning, enables high communication performance, and ensures only 15 milliseconds end-to-end transmission latency, and 10 microseconds high-precision network time synchronization. In the solution, only one network needs to be maintained to support collaborative operations. And 5G network slicing is used to guarantee the security and 99.999% reliability for the power distribution network. Such advantages have made the 5G MEC solution the first choice for grid operators looking to build smart grids. Let's take a look at exactly how the 5G MEC solution helps make smart grid a reality. First, traditional power grid devices are upgraded to smart devices with 5G modules or CPEs. Then, 5G base stations and the MEC network are constructed with network slices planned to meet diverse power system service requirements. With the 5G base stations and MEC network deployed, the 5G core network delivers local breakout policy to the MEC network to route power grid services to local servers for processing. Leveraging MEC edge computing and slice service isolation capabilities, the solution can support multiple intelligent service applications of power systems in terms of low latency, high reliability, high bandwidth, and data transmission within the campus. What are the benefits of 5G smart grid? 1. For power transmission networks, the efficiency of inspection is 80 times higher, and the labor cost is 30% lower. Using manual inspection, it takes about 6 hours to inspect a tower, with half an hour spent just climbing the tower. Inspecting all towers takes 15 to 20 days. By using 5G drones and intelligent HD video for inspection, it takes only 2 hours to remotely monitor the power transmission network, generate warnings about risks, and determine faults, ensuring more flexible and safe inspection for power transmission networks. 2. The operation efficiency at substations is 2.7 times higher. A typical substation involves about 1,330 inspection items, covering a plethora of devices working in a complex environment. Manual inspection of one substation takes about 3 days. Using 5G robots and intelligent HD video, it takes only 1 hour or so to complete status detection, intelligent inspection, and safety management for a substation, achieving unattended inspection. 3. The 5G low latency feature enables fast and accurate fault locating and self-healing in non-fault areas on a power distribution network, improving the reliability and flexibility of the distribution network. Compared with differential protection based on optical fibers, preliminary analysis estimates that the 5G solution uses only half optical cables, shortens the construction period by 8%, and reduces the cost by 90%. In short, the 5G and EC network implements real-time online management of power grid assets and power load awareness, helps power grid operators implement precise investment and planning, and greatly promotes the intelligent development of power grids.